Hey guys, welcome to my YouTube channel. So today we'll be solving just few questions, and these questions are based on the last video, um, and we'll be applying some equation of motion. So basically, we have four equation of motion. So I'll try to list them and explain them before we solve this question. But I won't be deriving them because I didn't plan to do that in this video. Maybe the next video I'll show how to derive this equation, but I'm gonna list them now. So we have v equals to u plus at, then we have 2, we have v square equals to u square plus 2as, then we have 3, we have s equals to ut plus half at square, then we have s equals to v plus u over t. Now I'm going to try and explain all these parameters, the v, the u, the a, the t, the s. Now v means final velocity. Now what do I mean by final velocity? Definitely for us to have a final, there's an initial. So u means initial, u is initial velocity. So what do I mean by final velocity? What do I mean by initial velocity? Let's imagine a car wants to move a distance. A car wants to move a distance. Now, presently the car is at rest. Now, the initial velocity will be 0. Why? Because the car isn't moving. But immediately the car starts moving, it has an acceleration and it has a velocity. Now, the velocity at which the car moves from A to B will be called final velocity. Hope I'm clear. So initial velocity is just the velocity before movement, and the final velocity is the velocity after movement. So it's as simple as that. So what other parameters do we have? We have s. S is distance. S is distance. This is just difference between 2 points, A and B. Distance. A and B distance. And we have t. So t stands for time. That is time taking. Time taking to complete a motion, since we are dealing with motion. So these are basically the four equations of motion, and we can apply them to solve these problems. So let's start with the first questions. The first question, it says a man runs a distance of 1 kilometer. So anytime I'm trying to solve a question, to make it easier, I list out the parameters. Now when you list out these parameters, it gives you an edge of which equation of motion you are going to use and how you are going to apply them. So if you look at the first question, it says a man runs a distance of 1 kilometer in 5 minutes. His average speed is what? So now we have distance. Question 1. Solution to question. So we have distance, which is 1.0 kilometers, and we have time. Did they give us time? Yeah, they said time is 5 minutes. 5 minutes. Good. Now we all know our standard unit in physics is meters, and this is in minutes. We have to convert this to seconds and convert this to meters. So how do we do that? So if you convert 1 kilometer to meter, that's 1000 meter. And if you convert 50 minutes to seconds, that's literally 5 times 60. That's 300 seconds, if I'm correct. Yeah. Because we all know that We all know that 60 minutes, 60 minutes, sorry, 1 minute. We all know, we all know that 1 minute we give 60 seconds. So 5 minutes we give how many seconds? We just cross multiply, just simple arithmetic. So we have 300 seconds. Now, what did they say? They said we should calculate the average speed, right? They said we should calculate the average speed. So speed, formula for speed is distance over time. Now speed was our distance 1000, then time 300. So we do the division. So basically our speed is 10 meter per second. How do we have meters? Because here is meter and here is seconds. So definitely meter per second. So that's the unit. So this for question 1. So let's move to question 2. Let's move to question 2. I want to be sure we didn't make any mistake. Oh, sorry. Please bear with me. So we divided this. So that's 10 divided by 3. And if you do 10 divided by 3, I think that's 3.3 meter per second. Yeah, this is your final answer. Yeah, C. And question number 2 says a car traveling at a uniform speed. I will explain what uniform speed is. Of 100 km per hour spends 15 minutes moving from point A to point B. The distance between point A to point B is. So now I'll try and interpret the question. Now the question says a car moving with a speed, uniform speed. What does it mean to be uniform? It means from point A to point B, there was no change in speed. That's just basically the meaning of uniform speed. So the speed was constant. So 11 km per hour. And so they give us speed to be 11 km per hour, and they give us time. They give us time to be 5 minutes. Now, what did they say we should look for? They say, I'm reading question 2 now. They say the distance between A and B, and you can see our options is in kilometers, so we don't really need to convert any units except from the 15 minutes. We have to convert it to hour because our speed is in kilometer per hour. So when you do that, so we know speed equals to distance over time, right? This is in minutes. So how do we convert this to hour? We all know that 60 minutes, right, is 1 hour. So 5 minutes will be what? That will be 5 divided by 60 hours. That's just literally what it means. So if we do distance over time, that's we have to look for distance, right? So if we have to look for distance, we were given speed to be 1000, then distance over 5 divided by 60. I think that's 0.083, if I'm correct. Yeah, 0.3083. So all you just do is cross multiply, and when you do that, multiply by 1000. So that's 83.33 meters. Hopefully I'm correct. Let's check. Nope. I think we made a mistake somewhere. Oh, I know where I made my mistake, sorry. This is 15 minutes, not 5 minutes. So let's do let's do 15 divided by 60. So this is 0.25. So this is 0.25 hours. So I'll replace that here. Sorry. So 0.25. So if you multiply that by 1000, so we have is it 1100? 100, sorry. So you multiply by 100, that's we have 25 meters. So our answer is B. Yeah. So the next question is a train with an initial velocity. Okay. Remember I said initial velocity is u. Okay. Initial velocity of 20 meters per second is subjected to uniform deceleration. So deceleration is just the opposite of acceleration. So they said the time required to bring the train to a complete halt is, this complete halt means the final velocity is 0 because it's stopping, right? So it has an initial velocity of 20 and a deceleration of 2, and they say you should find the time. So looking at this for equation of motion, in our question we were given initial velocity. Final velocity is definitely 0 because they said the time required to bring the train to a complete halt is what? So final velocity is 0. We have to look for our deceleration. Sorry, we have to look for our time. We will give it deceleration. So question 3 goes this way. So we have final velocity to be 0. We have initial velocity to be 20 meters per second. Then we have our time. I will check again. Then we have to look for deceleration or acceleration. So I'll be using equation of motion, v equals to u plus at. All you just do is just substitute these values in it. Because we are asked to look for deceleration, our answer should be negative. So let me check the question again. Question 3, deceleration 2. Okay, deceleration is 2. Okay, we have to look for time. Deceleration is 2 meters per second square. This is definitely negative. So v equals to 0, u equals to 20, and this is minus because it's deceleration. This will change to minus. Then we have 2 into t. We are looking for time. So when we solve this comes over here. Just comes over here. This is minus 20 equals to minus 2t. Now this get away with this. Then we have t equals to 10 seconds. So it took the car to complete its movement in 10 seconds. So I think our answer is B. Yeah. So question 4, it said a body accelerates uniformly. I explain what uniform means, meaning no change. It's constant. So if they say uniform acceleration, it means constant acceleration. There's no increase, there's no decrease, just constant. So a body accelerates uniformly from rest. Now when you hear from rest, it means your initial velocity is 0, meaning the body was constant, like it was stagnant. The body was stagnant before it actually moved. So when a body is stagnant, it has no force acting on it, which makes the velocity 0, right? So a body accelerates uniformly from rest at 3 meters per second. Its velocity after traveling a distance of 24 meters is what? So we have to look for what? Final velocity. We say the velocity after traveling, that is after moving. So we have acceleration and we have distance. Okay, acceleration, question number 4. We're giving acceleration to be 3 meters per second square. Then we have distance covered meter. So they say find the velocity after it covered 24 meters. Now this is a car. Let me just draw a circle. Yeah. At this point. Now, at this point, what is happening? The first thing that is happening to this car is that there's no force, so no movement. It is stagnant. Then two, it has zero velocity. Zero velocity. So because of that, our initial velocity u is 0. Right? Now it starts to move with a uniform acceleration to a point B. Now it covers a distance of 24 meters, right? Now we are asked to calculate the velocity with which it's used to cover these 24 meters. It's simple. So now from our equation of motion, I will try and rewrite it. We have v equals to u plus at. We have v squared equals to u squared plus 2as. We have v xs equals to ut plus half at squared, and we have s equals to v plus u over 2. I'm not sure about this, but I think this should be it. Alright, so trying to solve this, we are trying to look for v. We know our initial is 0. We have this, we have distance, which is also equals to s, then a. So what formula do you think is best to solve this question? Because what we are looking for now is v. So I think I'll go for this formula because it has every parameters. So v square. So using that formula, we have v square equals to u square, which is 0, plus 2a, which is 3 multiplied by 24. So try and solving this. That's 2 square. So let me multiply the 3 times 2, that's 6. 6 multiplied by 24. That's 144. You will find the square root of this. So your v is 12 meter per seconds. So that's our final answer. Let's check. Yeah, 12 meter per second. That's D. Okay, now question 5 says the time taken for the body in question 4 to cover the distance. Now, from my explanation, I said it moves from here to here. So it covered 24 meters. It took this velocity, right? This 12 meter per second. Then they said we should calculate the time. So you can easily use this formula since we have our v. So v equals to u plus 80. So that will be 12 into u is 0, remember, at rest, plus a, which was given, which is 3 into bracket t. That's what we are looking for. So 12 into 3t. So t equals to 4 seconds. So that's our answer. It's very straightforward. So for our last question for today, they said a body accelerates uniformly from rest at 6 meters per second for 8 seconds, and then decelerates uniformly to rest in the next 5 seconds. Calculate the magnitude of the deceleration. So if you look at this question, they said a body accelerates uniformly, that is with a uniform acceleration, at 6 meters per second for 8 seconds, then decelerates uniformly to rest for the next 5 seconds. Calculate the magnitude of this deceleration. So what we will do here is question 6. So for a body, let's say this is our body, accelerate to this point for 8 seconds, right? Let me check. For 8 seconds, 6 meters per second square, then decelerate in the next 5 seconds. So the body accelerates. So we have accelerate, sorry, 6 uh, 6 meter per second square. Then the time taken for this acceleration is 8 seconds. Then there was a deceleration for 5 seconds. Now we were asked to calculate the deceleration. So how do we go about this? This question is quite technical, but it's something we can solve. So it means when there was an acceleration, it took 8 seconds, right? That means there's a distance covered for this. Now for the next 5 seconds, it decelerated. So let us get the distance covered, then we will see if we can actually solve this. Okay, so looking at this, we have v equals to u plus 80. I'm trying to rewrite the formulas again. V square equals to u square plus 2as. We have s equals to ut plus half at square, right? Now we have at, we are looking for distance, which is also s. I think we can use this, right? So s is ut, where we giving you, if you read the question, u is initial velocity, the body accelerating from rest, so u is definitely 0. U is definitely 0. So let's try and solve that. So this 0 plus half times a, what's my a? 6, multiplied by t squared, that's 8 square. So we solve this. So the distance covered, this 103. We solve this, the distance covered is 192 meters. Now trying to solve the magnitude of the deceleration in the next 5 seconds. How do we go about that? So now, since we have our distance, we can easily get our deceleration, which is a. So let's see if we can use this formula. V square equals to u square plus 2as. What's our final velocity? We don't know, but we know our initial velocity. Okay, trying to see. So we have v equals to u plus at. Okay, let's try and get our final velocity. So v equals to we were given a 6 times 8, since this is 0, right? So final velocity is 6 times 8. This is 48 meter per second square. Per seconds, not square, sorry. Okay, so we got our final velocity. So we got final velocity, we got distance traveled. Now we are looking for the deceleration at this time. So how can we get the deceleration at this time? Now we can just input this value back here, I think so. So final velocity is 48, u is still 0. Now we are getting this deceleration, which is also acceleration, x, into time taken, which is 5, right? So that will be 48 5x divided both side by 5 divided both side by 5. So x equals to 48 divided by 5. So that's 9.6 meter per second squared. So these are deceleration, which is option A, right? So this is the end of the video, and we were able to solve some questions. And my next video, I will try and solve more questions also, and see if I can derive how we come about these four equations of motion. So thank you for watching. Don't forget to subscribe, like, comments. You can ask questions in the comment section, and please turn on your notification button. Thank you for watching.